This conference will now be recorded.
Hi, good morning, good evening. Today we are having the SONiC, actually it's not necessarily SONiC, Psi for VOQ system subgroup meeting. Today we will talk about the Psi pipeline presented by Israel from Broadcom. Israel, could you please start?
Yeah. Hi, just 1 minute.
Yeah, I would suggest please rephrase to Psi for VOQ subsystem or system.
Hi. So, yeah, so last meeting, I was asked to go over the pipeline of a VOQ system. Now, I went over the pipeline of a unicast router, and actually, so we can do that. I didn't identify any major differences in the abstract level of such a pipeline. I think most of the differences are in the way you configure the system, but once all the tables are configured, then the pipeline itself is very much alike. So I have this set of slides, and we can go over them. But I also prepared the configuration part or an add route exercise in a VOQ system. So depending on what the audience wants to view, we can go over either one of them. I believe that if we go over the add route exercise and reach an agreement, then the pipeline will look very trivial once we have the understanding. Okay, so unless you want to jump to the pipeline, I would start with the add route exercise, if that's okay. Okay. So for the exercise, I used an example of a system with two SONiC VOQ switch devices. One is called switch ID 0, the other one is called switch ID 2. One is managed by SONiC 0, the other one is managed by SONiC 1. And there are additional two fabric devices. They are managed by another image of SONiC that is not running any BGP. And for that exercise, it will mostly be treated as a transparent device. Doesn't have much effect on the functionality of that system. Okay, so this is, you can see here the system ports numbering starting from 0 to 8 on switch 0 and 9 to 17 on switch number 2. You have the local port numbering, the core port index, And in this exercise, system port number 12 is connected to router call. This is another router in the network. This router is advertising address 120 route 120.0.0.0/24, and the router interface is using the address 10.0.0.100, and the next stop ARP is 00.0.0.112.2.3.3.4.4. So this is the setup of the system, and I wanted to see how this route is being populated into the two SONiC systems, SONiC 0 and SONiC 1. Okay, any questions about the exercise system? So I assume that all the initialization of the system is according to what we have discussed in the previous calls, meaning that you have to declare all the local ports, and you have to have each SONiC will have a list of all the system ports, including its own system ports, and we'll have another list of the public ports, etc. Yeah. So we are after the initialization phase, and now we want to add the route. So first step that we have to do is to create a router interface. So I will start with the SONiC number 1, which is the SONiC with the local router interface. So the router interface is local to that device. And the color scheme that I try to use in this slide is that blue represent SONiC calls or SONiC objects, and the purple represent new stuff or changes to an existing API. So on SONiC number 1, we create router interface. This is an existing API call. You call it with VRF. I'm using the default VRF. It doesn't matter here. And then the change is that we have to change the header of the router interface create and enable it to also accept system port and not only a local port. Okay, so VRF equals 0, system port equals 12. The MAC of the router interface, I choose 000012345678. And I will use just the port default VLAN, or maybe there is an option not to use the VLAN at all, because I'm only concerned about port level router interface, not the port VLAN or anything alike. And the result of that SONiC call will be a SI object. I gave it a name, brief, system 1, router 4. Okay, any questions? Okay. So now there's
Israel, quick question. So in case if this if you insert a different card, will the system port numbers will change, or how do you expect that to go? So let's say you inserted the switch SONiC 1 instance was there, then SONiC 0 was there. Let's say we insert 1.5, the middle of it, or something like the slot is got inserted. The system port will change.
I'm not sure I got the question fully.
Sorry, Israel. So my question is, sorry about that. My question is the system port 12 the example you're taking? What is there a chance of the number being changed when the line card goes up and down, or the device goes up and down?
Of course, there is a chance, but you know, you want to run before we walk. Let's try to walk before we run.
Okay. Sure.
Okay. So okay. So moving to device to the other SONiC 0. Okay. So now there is a need for a mediator. I was thinking about some database. I call it a VOQ system database, but any name is acceptable, whatever name. But the thinking behind this database is that this database is a database for synchronizing object creation and other information across all the VOQ SONiC images. So, for example, SONiC F0 don't have to follow this database, but any VOQ SONiC like SONiC 0 and SONiC 1, they need to have an instance of that database, and in that database, across that database, we synchronize objects and other information between the different SONiC images. Now, since we are a SI working group, so I really, you know, procedure-wise, I don't know how to, you know, make a progress with this database, but clearly this is a SONiC database and not a SI database. And the synchronization needs to be in the SONiC level and not in the SI level.
Yeah, I think you could just make this assumption very clearly. Yeah.
Okay. Okay, so we should think how we. Okay, for now, let's assume we have this database, and I think that one action item is to see how we ratify or propose this database and etc. How we standardize this database or push this database into SONiC.
Correct. And also basically the information that is needed for the NOS to synchronize how it's communicated, that would be the scope of the site. Yeah.
One question here. This is Ishwaran. So the VOQ system DB, it synchronizes object creations. But I mean, by that we mean it's not the actual object, right? I think this is some information that represents the ref.
Can you repeat?
So the information that needs to be in this database, this is not the actual object, right? So this has to be some information, for example, the outlive index. I think, so it's not clear from this sentence, what do we need to synchronize for the ref?
Yeah, so, okay. So specifically for this, once, so, okay, my assumption is that each device is creating the ref for its own local port. Although it is using a system port ID, it is for its own local port. And somehow it should trigger other devices once it has the router, the router interface on SONiC 1, other SONiC in the system needs to be aware of that, and this should trigger the creation of router interface on the other device. Now, if it's a handle, if it's, you can, so I just put here like a name, I call it RIF System 1 R4, but you can also call it RIF System 1 System Port 12.
Got it.
Of course,
yeah,
the object is a SI object, so of course you cannot put in this database a SI object, but you can have some handle, a string, I don't know, something to that you can access that will trigger the creation of router interfaces on other SONiC systems, on other SONiC images. So this router interface update in the VOQ system database should trigger a creation of router interface on all the other SONiC images. So the creation on SONiC 0 is very much alike. Of course, it will get a SI object which is local to SONiC 0. So I call it RIF SONiC 0 R4. Or again, you can call it port 12. It doesn't really matter. Okay, so this is router interface. So in this way, all the router interfaces across the entire system are synchronized or are coherent across all the devices in the system, all the VOQ devices in the system. Maybe I should.
Israel, one question on this. The application can assign the router interface ID here, right? It does not need to be assigned by SI.
Sorry, can you repeat?
Can the application assign the router interface ID instead of taking it from SI, or does it need to create it on SI on one of the ASICs and then pass it over?
So router interface is a SI object. When you create router interface, it's a SI object. Now the VOQ system database, so this is something I'm less my comfort zone to tell you how SI objects should be synchronized across SONiC. But we can think about different methods of synchronizing it. I really don't have any incline towards one way or another. Is this answering your question, or?
No, I was asking, Trey, the router interface ID is assigned by SI when you create it, right? The SI
Right.
object ID. And now, could it also be pushed down from the application as part of the creation so that we can deterministically push router interface IDs from an application layer when you're dealing with multiple ASICs?
No, I'm afraid this is not a healthy way to do it. Not a good design, I would say. I mean, you should trigger the creation, but the management of the object should be scoped to that SI and that SI only. I'm afraid that pushing objects from the outside into SI.
So when you pass it across multiple ASICs, right? When you pass it from one ASIC to another, you're technically pushing it from above.
No,
Yes.
But he's not passing the object of psi. He's passing the index. So in order to
Right.
create the object in the right, so the idea, and I totally agree with it, that the object, the psi object are maintained, distributed in each box. The only thing that need to be synchronized is are the index. What are the parameters that I use in order to create the object? And those must be the same. So if the parameter are system port and MAC and VLAN, they should be, those parameters should be synced between the devices.
So can we assign the index outside then in the application and push it down?
No, if you're suggesting to create the object in the application and push the object to psi, I think it is a major change in psi, and I don't think we should go that way. That psi get an object outside and need to understand what they are actually.
I mean, I think what Shrikant is trying to ask is like, it's not an object it's creating. We are saying the index itself has to be. I mean, can we assign the index?
What is an index?
The outlive index, let's say, right? The outlive index. Okay, but
but for now, I'm not using any outlive index. This is something else. Let's wait for the outlive index.
Okay. So the RIF index, for example, so the RIF index itself has to be, so okay, when we synchronize, I mean, the question is, the index, when we call this object create and creates a RIF, the output is an ID. That ID, can it be assigned out? I mean, instead of first call to create
again,
yeah.
I don't think we should get involved into psi object allocation. This is a local psi object, and I don't think it will be wise to force it from the upper layer. Psi is managing its own object. However, we only need to know who is, quote unquote, the owner of the router interface, which is the SONiC with that router interface local to it, one of its own ports. And once it is created on that owner, all the other SONiC needs to create it as well. So we just need to trigger the creation. And the actual object number or index, it doesn't matter.
So you're saying that in this case of the example you're showing, on SONiC 0, when I create the router interface for system port 12, which is on SONiC 1, I don't need to pass it any identifiers that were allocated by SONiC 0, by SONiC 1.
Right.
So
right. I just need some handle. I need some handle, some string or a text that will tell me that on that system port there was a creation of a router interface.
Okay, so in this example, you're showing port default VLAN. So you're showing a port default VLAN here. So your expectation is that with this set of parameters being passed, you don't need to take the result of what happened on SONiC 1 and pass it to SONiC 0. You can do it deterministically.
Right, because let me maybe articulate one implication. So the psi implementation needs to distinguish between creating a router interface over its own ports and over a remote port. For its own port, there is a full set of databases tables that needs to be configured, updated, etc. When it is created over a remote port, there is a much less set of databases and tables that needs to be updated. However, the output of the create function is the same. It's the psi object.
Okay, so
but
now in
the
this
sequence,
So in this example, I see that you're passing port default VLAN as a parameter, right?
Right.
How would SONiC 0 know the port default VLAN that was used on SONiC 1? Is your expectation that it is the same value that is passed in both cases? In which case, both the system port ID and that VLAN need to be global parameters as
Okay.
opposed to just the system port, right?
Okay. So when I wrote this slide, my intention is that you put it some value, VLAN equal something. Okay. However, going into SONiC 1, router interface create will not do anything with that VLAN because it will not have to configure any table that needs this parameter.
Okay, so on SONiC 1, we don't need to pass it down, I guess. Now on SONiC 0,
You will.
do I not need it as well, or do I?
So in order to keep the header file the same, I put it in the creation header. However, from what we have discussed internally with our site team, looks like it's like a void call that just create a SI object. There's not much to configure on the remote on SONiC 0.
Okay, so to confirm again, so your expectation is that the VRF system port and MAC address are needed, but we really don't need to worry about that VLAN ID value that is shown.
Also, the MAC address is not much needed.
Okay. So we don't need to have those. So effectively, we are saying create routing interface on system port 12, and we really don't need to worry about passing a VLAN ID.
Right. So you will see, I had this debate on another call where I don't need a parameter whether to keep it or to remove it. So I try to keep it just to make it simple.
So the reason I'm asking this question is because we did experience when we tried to implement something with the Jericho 2s that the VLAN ID actually had to be provided. Otherwise, it wasn't getting processed correctly for specifically this kind of a topology you're showing. But if you expect that whatever is implemented going forward will make it not necessary, that's good news. I wasn't just sure that it got ignored, right? I just wanted to make sure that we weren't ignoring something that was needed.
Again, I think that we just to keep it simple and safe, I would still keep it. Our understanding is that it's not needed on SONiC 0. However, just to make it simple and less disruptive is just to keep it.
Okay, thanks. So our experience has been that we needed it, but okay, if you're keeping it, it's good news anyway.
I had a question on SONiC 1. Today there is a RIF create with local port ID, right? So would we have just one RIF with system port, or we expect a local RIF and a system port RIF?
So just one creation with the system port. So the SI can move between system port and local port.
Okay. Okay.
On the same question, what Srikanth was asking, so in question to Israel and Srikanth, that we could create a multiple RIF on a same system port, right? The different VLAN numbers.
Okay, so for now I'm avoiding this. If you go to the pipeline view, I'm just referring to a router port.
Okay. Yep. The router port. Yeah. Okay.
Okay. So after we have the router interface, next thing that we want to configure to create is a neighbor. So again, I'm starting with SONiC 1, and I'm creating a neighbor entry. The IP that I fill in is 10.0.0.0.100, and the MAC is the MAC of router 4, which is 0.0.0.112.2.3.3.4.4. And I use the router interface object, which I got from the create router interface. And basically, this neighbor will now represent our 4's next hop. Now, since the RIF is system port is local to that device, then the SI will go and create what we call an outlist entry. Other may call it in different names. It is being called like rewrite entry. Some architecture will call it an ARP entry. Some architecture will call it just egress entry. I'm using this terminology, but I mean, I don't care what is the final name. I find it useful to call it outlist, logical interface, but again, we can call it in a different name. However, we have to create such an entry and fill it with the destination MAC address that needs to be written on packets that are sent to that neighbor, which is that MAC address. And so while we create this entry, we get an index to that entry. Okay, so I will later use that index. The outlist index R4. Also, we create a FEC entry, forwarding equivalent class entry, that points to system port 12, which is taken from the router interface, and contain the index to the leaf entry, to the rewrite entry. Okay, so two entries.
But this is describing, right? Yeah, but those are this is describing the hardware, not the SI. So logically, you create a neighbor. I'm just trying to, because you're using here your terminology, which is fine. I'm just trying to be generic. I'm not working in Broadcom, you know. So, so you're creating a neighbor entry pointing to the router port, and of course, that different hardware will have a different implementation. But in sign language, this is what you're creating. Cool, and you're getting an kind of an index to that entry.
Yeah, and I need some index. This is the important piece.
Yeah, right.
Okay,
so so one of your changes is that you're getting, again, this is kind of a SI index, not, this is now become a SI. You expect SI layer to...
Right.
Okay, cool.
To propagate that index.
Yeah, so...
Exactly.
Kind of a SI object index, whatever it will be. The name will be. Cool.
Not an object, it's like an index.
Of course, hardware English. Yeah. Something represent the hardware itself, not SI neighbor index, whatever you will go.
Yeah, whatever. So we need some index, okay?
Yeah.
We may call it a neighbor index, but however, the reason I'm reluctant to call it a neighbor index is because it can be used not only for neighbors, it can be used also for tunnels and structure like that. And also rewrite is, in my view, is not correct because we are not rewriting anything. We are creating a macler. We are not rewriting a macler. Anyway, so we will get some index. Again, this index is going to be synchronized over the VOQ system database, or whatever the name of that database will be. And this will trigger a create neighbor entry on SONiC 0. So again, we start with creating a neighbor on SONiC 1. This creation is doing some population of tables entries in switch ID number 2, and is propagating an index through the VOQ system database. That index in the VOQ system database will trigger the creation of neighbor on the other SONiC devices. Okay, and now we have somewhat a bigger change to the SCI API. This is actually the biggest change, and so I think we can keep it just, again, to be simple and make as minimal changes as possible. So we call it with the same.
Actually, the previous one is a big change because currently nothing is assumed that everything is synchronous.
Right.
Are you proposing some kind of an event mechanism? How you are going to get back? Because it's one side, like it's how you supposed to get back this object ID?
What do you mean by get back?
This is a real hardware index. It's not like a SCI object.
Okay, but
I guess,
you can
right?
treat it as a SCI object. Right. So
no,
treat
the question
it as a string.
Yes, man. I understand software-wise. You can treat it as whatever you like. The question is now, are you forcing this API to be synchronous?
Yes.
Okay, so it's kind of another assumption that you must, like, I don't think that for now there is an assumption that if you are calling SCI, you're getting the response back when the entry is actually in the hardware.
Actually, I'm taking a little bit back what I said. I'm not asking it to be synchronous. I'm asking let's call it the non-owner devices to use some string that was set by the owner device. It's not like a distributed election of what value to use. There is an owner. Okay, there is an owner, a clear owner. That owner is dictating some string index. Again, we can call it in many ways.
Okay.
And the non-owners, if they want to use it, have to use that string index, whatever.
Okay.
And there can be only one and only one owner.
Cool.
Yeah, to Matty, I mean, there is an asynchronous, the SCI call itself has to return an index, and that can be, that call is a synchronous call, right? If that's the question.
No, I was trying to figure out whether it's mandated the entry will be in the hardware, or is it just a unique index they must agree on. And I think that the answer was clear. Like, it's just an agreed index. So as long as it's unique and they all agree on the same index, it is good enough, right?
It's unique within that owner scope, right? It is not. I mean, now it will be unique across the system is based upon the owner and the index.
Right.
It has to come.
Let me clarify. It is unique for the for per owner. So each owner, each SONiC, is owning a set of pointers and is the owner. And another owner can use the same index or the same string, but since these are two different entities. You follow, Mati? Or
Yes, I am. I totally follow. Did you think about how it will work with ISSU?
again, it's too far away. No.
Okay, cool.
Okay, so maybe I think one conclusion for me is that maybe we should start by clarifying
Scope.
no, clarifying what I mean by owner. Okay. So just to make sure everybody is aligned, every device is owning the router interfaces and the neighbors that are directly attached to his local port.
By the way, what happens if this is a lag between two devices?
Okay, so we took an assumption that there is no lag across devices.
Okay.
You know, you need some MLAG, etc.
No,
to complicate the
again,
system. Yeah.
A quick request. Can you clarify the scope, like what we are solving now and what is not solved? Like, otherwise we will stop bugging you with all kind of weird question.
Yeah, I think, okay, it's not in this presentation, but I think in the first presentation I put some disclaimers, like I'm not targeting multicast, I'm not targeting port VLANs, I'm not targeting lag across devices. Yeah, I will put it again. I will put it again.
Did you share
so,
it? By the way, is there? Did you share it in just me?
Yeah, I sent it to Rita, and she was supposed to upload it for the workshop. And I put the document. Yeah.
Yeah, I also sent to OCP. Let me follow up if it's being posted. Yeah, document I have not yet posted anywhere. Yeah, I think we discussed it could be in PL, but yeah, before that, it's good to find a place to upload it then. Yeah. Okay.
No, for me, I didn't see the scope, so it will be great if you just, again, not now, but if you can share a kind of a document saying this is the problem that I'm trying to solve, only router port, only router, only blah, 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 without ISSU, without that, it'd be very clear, and we won't bug you with a funny or weird question.
Okay, that's okay, you can bug. Okay, so again, I think Rita will handle that. And I also put on the SCI GitHub the document. It's not final document, but it got a lot of material, and you can read it. I mean, we will add stuff to it, but the parts that are already there, and there are like, I don't know how many pages, are pages that you are welcome to review and to send your notes. It's under the doc directory of the site. It's called proposal, VOQ system, or something like that.
Okay, perfect.
Okay. So we again triggered by this outlive index R4 in the VOQ system database. We create a neighbor entry with the same set of parameters as the owner, and one new parameter. Maybe I don't know how to call it. Let's call it index for now. And this index is the index that is passed through the VOQ system. Now, upon this create, what will happen in the site, just to maybe articulate the changes between the owner and the remote device. The remote device will create only part of the table, pointing to some of the tables that exist over the owner. Okay, so I believe in many architectures, VOQ architectures, it is split between what we typically call an ingress device and egress device. So some of the information is stored in tables on the ingress device, and other information is stored in tables on the egress device. Specifically for create neighbor, only the owner will populate the egress table, and all the other devices will populate the ingress table, pointing to that owner egress table.
I understand. By the way, how do you know what is the riff over here?
What is that, sorry?
The riff. On
The
SONiC
router
0. Yeah, because you don't have now the system port. So how do you know to correlate to the right riff?
Yeah. Yeah. So we need some pointing. So again, this is something that needs to be resolved together with this VOQ system DB. But remember that in the VOQ system DB, we said that we have riff S1 R4, right?
Mm-hmm. Yeah, if you forward the parameter like the VRF and the system port, probably we can retrieve the riff. But
Yeah.
without that, you cannot retrieve the riff.
Okay. So yeah.
Do you really need it, the riff, or you really need only the index?
I need the local riff. Yeah, I need the riff.
Okay.
From the riff, I get the system port that I have to use.
Okay.
Okay. So we created a router interface. We created a neighbor. And the next thing that we have to create is the next stop.
Can I ask you one question if you go back to the previous slide?
Yes.
So on SONiC 0, I am passing the outlive index R4, right? Is it possible that we could pass that parameter on both SONiC 0 and SONiC 1? Or does it only need to be passed? I mean, would we allow it being passed pushed down from application on SONiC 1. Because that's the only difference I see between the two calls is the second one has an extra parameter. If he pass that parameter down in SONiC 1, would that value be honored, or would it not be?
Yeah, so we can use, okay, we can use SONiC. We can use SONiC to translate. I mean, it doesn't have to be, yeah, so, okay. So the answer is yes, we can do that. We can do that, but it will not be the final index, not necessarily.
I mean, as long as it is the index that we pass to SONiC 0 later, I guess we're good.
Yeah. Okay, let me think about it. We might be able to do it. We say let's impose by SONiC.
Right, so this makes it a little more deterministic, right?
Yeah. I mean, in a relative simple system, it should work fine. In a big system, it may be problematic. Yeah, but yes, I mean, we can do it. So again, I'm just thinking in the back of my mind about cases where you need hundreds of thousands of such indices. Managing it by SONiC may not be the best way to do it, but
yes,
if
that's not the
if you are limited
right?
to
Yes.
if you are limited to few tens of thousands, then you can absolutely do it. Okay. Let me.
Thank you.
I took a note, and yes, it's a good idea.
Help the system design if that can be passed down, actually.
Right. Okay. I will check it with our SDK guys, and if it's possible, then yes, we can do it.
So and on, can you go back, Ishwar, on the previous slide?
Yeah.
So if we add the index, now both these APIs looks very similar. And how does the behavior or the implementation? One time it creates an outlive entry filled with a MAC. In another case, it is only a FEC entry pointing to system port 12 and using the outlive index R4. So if our parameters are pretty much similar, what is the other parameter to differentiate? Because of local systems in some port. Okay.
Okay, so I wrote it on the first call. On the second one, I omitted it, but basically the SI now internally needs to see if the router interface system port is local or not local to that device and will behave differently.
Okay, sounds good. Thanks.
Okay. Next thing is next hop, and basically there's not, so at least in our implementation, next hop is not very much, it's not doing much in the data plane, and therefore can be almost intact versus what it is today. So we call create next hop with the IP, the router interface, and we get a next hop SI object, sorry. I call it NH-S1R4. And this should be triggered by the create neighbor. Now, in the data plane, it doesn't do much, and so I don't see any need to change anything in the way it works.
Yeah.
Okay. 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 So finally, we can go and do the create route entry. So we start with the owner being SONiC 1. We do create route entry with VRF, the default VRF, the prefix that is propagated by BGP, 120.0.0.0.24, and the next stop, a pointer to the next stop object that we created in the previous step. What it does in the hardware is that actually it's in the hardware, we call it LPM. In the SI pipeline, it is called router table, but they are very similar. And we have a pointer there, so we create an entry with that key, the prefix, and the result is the pointer to the next one. That's it. Okay. So this is done. Yeah.
One more question. Yeah, I'm sorry, I was kind of recollecting that create neighbor. Can I go back to that slide? Sorry, Israel, because on the SONiC 0 create neighbor, you were expecting, yeah, you were expecting the MAC address to be passed on the SONiC 0, or doesn't matter?
No, on SONiC 0, if I am, yeah. So I said just for simplicity. And again, we don't. So the MAC address is basically the same information, contain the same information as this index, right?
The way we have used
this
it,
index.
Yeah, the way we have used it, like kind of, I mean, the thing was the index is passed. If index is passed, then we were, I mean, the MAC address for a SONiC 0 case, the MAC address need not be passed because it's not used at all, right? So it could be any value, I mean, it's just any value, but it's ignored because the index is what, because it makes sometimes it's simplicity to create this index. I mean, this create neighbor little upfront without waiting for the MAC to be resolved, at least on the remote non-owner devices. So it simplifies the sequence of the creations of the neighbors.
So let me see that I follow. You propose to use, instead of the MAC address, which is probably just a string, to use it to pass the index if it's the remote SONiC. Did I get it right, or?
Yeah, I mean, remote SONiC, we will pass any MAC, which is anything, and index is what important. The index and the IP address is what the index, I mean, very important. The other, the RIF itself, right? The RIF, you need the RIF, IP, and the index is mandatory elements.
So basically, what you are proposing, let's see that I got it right.
Optional, yeah.
This is what you propose, and then I don't need to change the call.
No. I would leave it MAC to be like this as the optional parameter, so it simplifies that way. So I'm saying that.
You're just saying that MAC should be an optional.
Yes, yeah, that's what I'm thinking.
Yeah. So again, I think we discussed it a few times in that call, and what I said that for simplicity, I think Yeah, I tend to keep it, just not to create too many differences, but I don't have a strong opinion either way.
Okay.
Israel, I think so even if it is not an optional argument, maybe we could, like, it doesn't matter what MAC address we feed in here, right? Like you could pass null and it will be okay. Is that the fair understanding?
Yeah, exactly. That's what I'm coming to.
Okay. So actually what you're saying, okay, let me see that I got it right.
Yeah, dummy or a null. Yeah.
Dummy. Yeah.
Yeah, dummy.
This is basically what you propose?
Yes. Yeah.
Okay. Yeah. It should work. Okay. So okay. So finally we add route. So again, on SONiC number 1, this is just a normal create route entry call, no changes. And also on SONiC 0, this is a normal create route entry. What needs to be synchronized is the next stop. So yeah, I think I didn't clarify it well, but so the BGP will associate this route with the interface of switch ID number 2, right? So the BGP running over 120.0.0.0.24. The BGP running on SONiC 1 will update that 120.0.0.24 is connected through interface, the interface on system port 12, whatever it is, right? And then it will transfer this information to BGP 0, to BGP on SONiC 0, which will associate it with a remote interface on SONiC 1.
Just a minute. What is remote? BGP will associate that with next stop, with some loopback address, not with the interface.
Yeah. BGP will associate it with no, when so yeah, so SONiC 1 BGP will associate it with a loopback address over port 12. You agree? Which is local port 3.
Yeah, but BGP does not know that it's port 12. For BGP knows what is the loopback address of that machine, the green machine over there, and some other entity in the system, like the neighbor table ARP, knows that this is actually behind port 12, right? BGP is pure IP, does not understand ports and VLANs and MAC addresses.
Right. And so therefore, I think that since we have the same next stop or a synchronized next stop, then it's the exact same call.
No, but you don't want to have the same next stop, because the BGP on SONiC 0 will see the packet behind SONiC 1. Again, you didn't explain how you are running BGP on that box. What are the peering, your members, like peering?
No, Can I answer the question? So in the next hop itself is a VOQ next hop on a SONiC 0, but that VOQ next hop is representing an IP next hop of SONiC 1. Is it like that way, right? So this is fine with the API perspective. This looks okay to us. Because the next hop S0 R4. Sorry, sure. Go ahead.
No, please repeat. I lost you in the beginning.
No, I said the next hop S0 R4 is some sort of VOQ next hop. It's sitting behind the VOQ, and I mean, when I say VOQ is like it's representing the remote device next hop, and in a SONiC land, a SI land, it is represented as an next hop SI object because we created using the index what we passed. The rest of the call looks very similar from a SI perspective, right? So it should be okay.
Right. From a SI point of view, this is clean, right? So you got a route being created against the next hop, and that's all legal in SI. I mean, how BGP learns about it is internal to the system. I guess that's all outside of SI.
Yeah. This looks very clean, just that the next hop NH S0R4 will have a type or something like that, you can say, but saying that it is created for a remote device neighbor using the index what we passed.
Yeah, but the index is the neighbor and the next hop does not contain the neighbor, the index of the neighbor. It's totally disaggregated, at least inside.
So, but from a SI layer point of view, it is just passing a next hop that SONiC 0 created earlier, right?
Right. It's not IP next hop, right? You can say it's a cell next hop.
Right. So I mean, SONiC 0 created this next hop earlier in the call flow that Israel showed, and now a route is pointing to that next hop. How did SONiC 0 find out about that route? I guess that's outside, I guess, to the scope of the immediate SI discussion. But it is a fairly completely legal SI operation, right? It's got a route pointing to a next hop.
So there is no change, right? I mean, I don't see any change in this API. The create route entry is as it is today. Is it right, Israel? You're not changing the create route entry.
Right. I mean, again, from the device point of view, again, I didn't detail all what is happening in the BGP and how the information is passed from SONiC 1 to SONiC 0, but the call itself is just like any other call. There's no need to change anything.
I think an important prerequisite is that here the BGP 0 on SONiC 0 and the BGP of SONiC 1 established neighbors BGP session between them. So when SONiC 1 learns the next hop, it will advertise to SONiC 0 by BGP protocol. So this next hop here, it's learned from at SONiC 0 BGP learned it from SONiC 1 BGP.
No, actually, this will be a challenger. So I'm not sure, but again, I do agree that this is kind of a SONiC issue and not SI issue. Because if you will run regular distributed BGP, SONiC 1 will learn the route behind SONiC 1 and not with the same next hop. So they will not share the same next hop actually. Right? SONiC 1 will see the green behind the green and SONiC 0 will see the green behind SONiC 1. So the next hop will be SONiC 1, not the green. And you want SONiC 0 to learn it behind the green, to have the same next hop.
So I believe there are ways in BGP, right, for SONiC 0 to see R4 as the next hop, right?
Yeah, again, it's solvable. It's SONiC work, but though it's different peering, so they both need to peer with the green, not between themselves, and then they will both see the same next hop.
Yeah.
So I guess if you agree that from a SI point of view, this looks clean, then that's a good outcome.
By the way, are we like 15 minutes beyond time already? So are we planning to continue?
Yeah, I think we probably should continue next time. Yeah.
Okay,
yeah,
so I will clean the slides, and maybe we will do a quick pass over the clean slide next time, and then we can go to the pipeline.
Okay. Do you mind after you clean this up, share this within the subgroup here, or you prefer to upload somewhere? Yeah.
No problem. I will send it to you, and you upload it to wherever it's more convenient to the forum. Okay.
Okay. Yeah. Thank you, Israel. Yeah. Thank you. I think we didn't do an introduction of the people who are attending. Maybe next time let's do some introduction. Yeah. Thank you so much. Yeah.
Okay.
Thanks, Israel.
Okay.
Thanks, everyone.
Thanks, everyone.
Thank you.
Bye.
Bye.
Thank you. Bye. Stay safe. Bye.